Okay, how's it, Chase? And welcome to your last lesson for the, basically your last lesson for the year, or in your syllabus. I'm sure we'll throw in a few more lessons here and there, but yeah. Today we're going to discuss definite integrals. Definite integrals. Okay. So, I start off here by discussing in the engineering field the equation displacement equals velocity times time. Okay. And they call it, they say S equals VT, whatever you want to call it. Okay. And graphically, what they're saying is, what this equation says, if velocity is constant, V, okay, you can have three possible situations. Velocity is constant, number one. Then velocity is increasing linearly with time, that's number two. And velocity increasing quadratically. It's number three. Okay? And they basically show you that, for example, here, let's look at the first one. And let's give this a velocity of 20 here. And let's call this 40 seconds. So after 20 seconds at after 40 seconds at 20 kilometers per hour, displacement equals velocity times time is equal to 20. Okay, this is meters per second. Sorry, meters per second, and this is seconds. So 20 times 40 is equal to 800 meters, right? And you'll notice that 20 and 40, we've actually calculated the area under this curve. Because we've taken, so basically we've got a square here under the curve. This is a square, and we've calculated its area in order to get our displacement. So now, what would happen if we wanted to calculate the displacement for this one? Okay, once again, let's say after 20 seconds, or 40 seconds, sorry, 40 seconds, and this velocity over there is 20. Do you agree that here we started at time 0, we were traveling at 20, and we continued at 20. Here we started at almost 0 and continued, right? So, how would we calculate the displacement in this case, or in this case, where the velocity was changing? Well, here, in the first one, we knew that velocity is the area under the curve, or the displacement was the area under the curve. And the same goes here. Displacement is the area under this curve, and the area under that curve. And the question is, how do we calculate this? And the answer here is to use the definite integral. Okay? So your book goes into a whole bunch of detail on page 718, which is not that important. 7-18, it's not that important, especially the first half of the page. The first half of the page, I mean the second half. The second half of the page, 718, not that important, it just becomes a bit confusing. But basically, what they're trying to tell you is, given a curve, so given a function, a function or a curve, y equals whatever, or just given a functional curve y, right? So let's draw that. So say we're given a curve, blah, 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 okay, and this, we call this y, okay. The area under y between two x points is calculated as area is equal to the integral from a to b of y dx. Okay, so the area under this curve, let's say we've got points, so the two x points we were talking about, let's call them here, let's define them here. So between points A and B, okay, so there's our two x points. The area under this curve, so the area under the curve is all of this red area here between points A and B, all of that area, right? Okay, so that's the area, is the integral of the function y between points A and B. Okay, area is the integral of the function y between points A and B. Okay, so how would we calculate something like that? Alright, so this is a definite integral, right? Let's first talk terminology. This is now a definite integral. Remember, we had our indefinite integral, which was integral of f of x dx, right? And that was equal to f of x, where f is the antiderivative, plus c. Okay? Now we've got a definite integral, which looks very similar. We have area equals the integral. The only thing that changes is a to b. So we put what they call limits of integration. F of x dx, and when we do this integration, we don't end up with a plus c, because this plus c is only for an indefinite integral. For a definite integral, we don't need the plus c. What we do end up with is something a bit more interesting. Right. Okay. And I'll explain to you what I've written here now. Okay. So, when I do an integral, so I say the integral of f of x dx, right? Now I'm going to just do an actual example on the right, so you can see what I mean. So if I take the integral of x squared dx, okay, that is equal to x cubed over 3 plus c. Mathematically written, that is equal to big F of x. Now big F of x is the antiderivative. So big F of x is the antiderivative, which is this piece right here. That is our antiderivative. Okay. So if I said, if we look at our notations, so there is small f, which is x squared, and there is big F, which is our antiderivative, which is that value there. Okay? So if I said calculate f of 2 is going to be 2 substituted in there, so it's going to be 2 squared equals 4, right? And if I said calculate big F of 2, well, here's our antiderivative, so that's going to be 2 cubed over 3, which is equal to 8 over 3, right? So why I'm telling you this is so that you understand the concept of the antiderivative. So how do I calculate an indefinite integral? Well, here's your answer right here. So if I've got an indefinite integral between points A and B of a function, I get the antiderivative, which is what I get when I usually integrate. It would be this value in this case. I get my antiderivative, which is big F of x, and I evaluate it between my limits A and B. How do I do that? I take f of b, f of this upper limit, the top limit, or the final, minus f of a, which is the bottom limit, or the initial limit. Okay. So let's do an example of that. I'm going to write out the formula, and I'm going to show you exactly what I mean here. There's a couple of examples in your book. Let's see. Okay. So, here's what we're going to do. Example 29. But first I'm going to write this up here so you remember. The integral from a to b of f of x dx is equal to f of b, or rather the antiderivative of x between points a and b, which is equal to f of b minus f of a. Remember, big F versus small f. Big F is our antiderivative. So let's do it. So they say, calculate the area below the curve y equals x squared. Now x squared is in this case our f of x. Okay, that's not in the question. X squared is our f of x. So calculate the area below the curve y equals x squared between the boundaries x equals 0 and x equals 2, as shown in the graph. And they give you the graph, so I'll draw your graph for you. Looks like this, and they plot it there like that. This is y equals x squared, and here you've got your points x equals 0 and x equals 2 over here. So what they want is this area here. That's the area between x equals 0 and x equals 2. Right? Between those two boundaries. So, how do we do it? Well, let's follow our formula. So we know that area is equal to the integral from a to b. Now, a is always going to be your leftmost point, and b is going to be your rightmost point. Okay. A to b of f of x dx, which is equal to the integral from a to b of f of x, which was x squared dx. Okay, so now once we integrate this, so we take the normal integral just to get the antiderivative. The integral of x squared is, you can use your table or whatever method, it is x cubed over 3, right? Now this is our antiderivative, this is our big F of x, and we evaluate that between points A and B. Okay, and what are points A and B? Well, I said A is your leftmost x point, so that is 0, and B is your rightmost x point, so that is 2. And then we know that we evaluate, the final answer is going to be that when you've got this notation, this means calculate this function at this point and subtract this function at that point. So what are we saying? As per the formula, f of b minus f of a, where this is f. So f of b is f of 2, which is 2 cubed over 3 minus 0 cubed over 3, and our final answer is equal to 8 over 3. And that's your final answer. So that's how you do an indefinite integral. Okay, we're going to do a little bit more. Can't just stop there yet. Okay. Let's take a look at example 31. Example 31. It says, determine the area below the curve y equals x plus 1. With the limits, so between x equals 1 and x equals 4. So, how do we do it? Well, we know that area is the integral from a to b of f of x dx. So that is the integral. What are our limits? Our lower limit is x equals 1. Our higher limit is x equals 4. So, x equals 1, x equals 4 of f of x dx. And f of x is x plus 1 dx. Right? So what's the next step? We're going to just do our normal integral. We're just going to integrate this. And if we integrate that, we end up with the integral of x is x squared over 2. The integral of 1 is x. Yeah, okay. And we're going to evaluate this entire bracket between the points 1 and 4. Okay, so what does that mean? We're going to substitute 4 into this expression, and then we're going to subtract 1 substituted into that expression. So that is going to be equal to the final minus the initial. Final minus initial. So we go 4 squared over 2 plus 4, right? Minus, then we're going to substitute this in, minus 1 squared over 2 plus 1. Right? So now we can just simplify and calculate our final answer. So that is 16 over 2 plus 4 minus 1 over 2 plus 1. That is equal to 8 plus 4 is 12 minus 3 over 2. And you can pop that into your calculator. Oh wait, I've got the answer here. That is equal to 10,5. And they want you to say square units. 10,5 square units. Okay. That's as easy as that. That's how you do a definite integral. And also, once again, with this whole integration section, KhanAcademy.com is excellent. You can find pretty much everything you need to know there if what I'm telling you isn't helpful enough. Okay. And let's just cover the last section here in your book, and that is section 7.4. Okay. Section 7.4 talks about negative area. So we're always talking about area under a curve here with integrals, especially definite integral is the area under a curve. But you get a positive area and a negative area. So let's look at this example where you would have a straight line. And they would say evaluate between negative 2 and 2. So find the area under the curve. So now, if we take a look at this, any area that sits above the x-axis is going to be positive area. This is just how it is. Okay? And any area that sits below the x-axis is negative area. Okay. So we've got red So above the x-axis is positive area, and below the x-axis is negative area. Okay, and that's basically all you need to know. So let's quickly do an example like this. So let's do this exact example they gave, which says calculate the area below the curve y equals x between the limits x equals 2 and x equals negative 2. Right? So this graph looks like this. It's the line y equals x between 2 and minus 2. Okay. So we know that the area is equal to the integral from our lowest x point to our highest x point. So minus 2 to 2 of f of x, which is just x dx, that is equal to, right? The integral of x is x squared over 2 evaluated between minus 2 and 2. Okay, so that is equal to x squared, right? Substitute in the final, 2 squared over 2 minus, substitute in the initial, which is this one, minus 2 squared over 2, which is equal to 4 over 2 minus 4 over 2, which is equal to 0. And now the question is, wait, is the area under the curve really 0? Well, yes, it is. Because if we look at this graph, the area here above the line on the right hand side is exactly equal to the area below the line on the left hand side. So the total area under the curve between these 2 points is 0, because we've got a negative area and we've got a positive area, and those two have the same magnitudes. So they cancel out, and our total area under the curve is 0. If we had the case where we had the same function, let's just do it. The same function, y equals x, I drew that really badly, y equals x, except we went from minus 2 to 3. Okay? Then, obviously, the area here is going to be bigger than the area here. So the area above the x-axis is going to be bigger than the area below the x-axis. And for that reason, when we do our integral, so area equals the integral from minus 2 to 3 of x dx, and that is then equal to x squared over 2 from minus 2 to 3, which is equal to 3 squared over 2 minus 2 squared over 2, which is equal to 9 over 2 minus 4 over 2. Okay, which is 4, 5 minus 2 equals 2,5. Okay, so can you see that obviously now, because our positive area here, the area above the x-axis, or the positive area under the curve, is much bigger than the negative area under the curve, and that's why our total area under the curve between those 2 points is positive. Okay, and now, as an additional example, if we had done the same function, y equals x, but now we've got a larger negative area, so we go from minus 3 to 2, we do our integral there, then our positive area is less than so our negative area is bigger than our positive area, right? You can see that visually. the negative area is bigger than our positive area. So our total area under the curve will be negative. So let's calculate it. Area equals the integral from minus 3 to 2 of x dx equals x squared over 2 evaluated from minus 3 to 2. So that is equal to, we substitute the final minus the initial. So 2 squared over 2 minus 3 squared over 2. And that is equal to 4 over 2 minus 9 over 2, which is equal to 2 minus 4, 5, which is equal to negative 2, 5. So of course, because our negative area is bigger than our positive area, we ended up with our total area between those 2 points being negative. And that brings us to the end of your syllabus. We've covered pretty much everything that there is to cover in integrals. I will try to squeeze in that video for you about logs and exponents that you asked for, because I know you want one of those. So we can definitely squeeze that in. I'll do it next week for you. You just need to let me know what exactly you want me to cover, and I'll try to cover it. But yeah, and then anything between now and your exam, anything you need, like any questions, anything that needs clarification, let me know. You can come to me personally. We can sit and chat about whatever sections you need help with. Alternatively, you can message me questions that you have, and I can make videos explaining those specific questions. Like anything you need to help you with, just let me know. And we'll cover it before your exam. And we'll do our best so that you can try and nail it. Remember to practice lots and lots of problems. Like read the section, watch my video, practice the problems, and yeah, you should be fine. All the best, man. We'll be in contact. Cheers.